Hello students, today we are going to learn our chapter number 9 ray optics, and we will derive the formula for here the refractive index, and we will know about the formula of lens. So now first of all we will see the figure here, that here we are having the object O, and the image of this object O is finally we got here I, which is at the distance from M, the distance is V. We are having two mediums. First one medium is having refractive index N1 and the second one is having refractive index N2. The rays, incident rays from object O will be from O to N, and from N that will go to I. So here the incident angle is I, here refracted angle is R. So in this way we can see figure, and now we will here write some formulas. So here we can see this figure, and here we have the triangle NOM, which is right angle triangle. So we can write here that 10 NOM is equal to 10 NOM. So this is our angle. So the formula of 10, that is adjacent upon opposite upon adjacent. So the opposite side is NM and the adjacent side is OM. So we can write here NM upon OM. Now we will write the formula for NCM. So 10 NCM, 10 angle NCM, that will be equal to NCM. So the opposite of C, that is MN, and adjacent is MC. So we can write NM upon MC. And now we will write the formula for 10 angle NIM. So we have 10 NIM, that is equal to, the opposite side of I is MN and the adjacent side is MI. So we can write here MN upon MI. Here our MN upon MI. So here MN upon MI. Now in triangle ONC, we have the exterior angle is I over here. So the exterior angle for triangle NOC, we will write for triangle NOC, we have exterior angle I. So I, that will be equal to summation of interior angles. So the exterior angle I is equal to interior angle NOM plus NCM. NOM plus NCM. So we can write NOM plus NCM. So this is the formula which we will got here. So we will write the formula NOM and NCM. So NOM, that is equal to NM upon OM. So I is equal to NM upon OM plus NCM. NCM, that is equal to NM upon MC. So this is the formula for I. Now we will derive the formula for R. R is our refracted angle. So the R is the exterior angle for triangle NOC. So that will be also the exterior angle. So we will write here that NOM plus NCM. NIM. So that is also the exterior angle. So we can write here similarly R plus NIM. R plus NIM. So these are two interior angles and the exterior angle is NCM. So we can write that for triangle NCM, for triangle NCI, we will write here NCI. For triangle NCI, the exterior angle is NCM. The exterior angle is NCM. So we will have here NCM. So the angle NCM. So this is our angle NCM. That will be equal to the summation of interior angle. So the first interior angle is R. So we can write here R and plus here we have NIM. So the angle NIM. So we can write here R is equal to angle NCM minus NIM. So R is equal to NCM minus NIM. So we will put the value for R over here. So we have the formula for R is equal to NCM, the value of angle NCM. So we have the value of NCM, that is NM upon MC. So we can write here NM upon MC minus we have the angle NIM. So the value of NIM, that is MN upon MI. So we can write here NM upon MI. So here we have the value of I and R over here. This is the example value of the I and this is our value of R. So value of angle I and R we are having here. So now by Snell's law, we can write here N1 sin I is equal to N2 sin R. Or for small angle, we can write here N1I is equal to N2 R. N1I equal to N2 R. So we will put the value of I and R over here. So we can write N1 into bracket the value of I, which is Nm upon OM plus Nm upon MC, and here the value N2 into R, the value of R is here Nm upon MC minus Nm upon Mi. So we can write here Nm upon Mi. This is our value. Now the Nm will be cancelled from numerator because that will be common here and that will be cancelled from both the sides. So we have the formula N1 upon OM plus N1 upon MC equal to N2 upon MC minus N2 upon Mi, because Nm will be cancelled. So now we have the formula N1 upon OM plus N2 upon Mi, that will become here. So we have N1 upon OM plus N2 upon Mi equal to N2 upon MC. So N2 upon MC minus N1 upon MC. So MC is the common denominator. So we can write here N2 minus N1 upon MC. Now we will put the value of OM, MI and MC. So we will put the value here considering sign convention. We have the value of OM, the value of OM, that is our object distance, that will be minus U. The value of MI, which is our image distance, that is equal to V, and the value of MC, the value of M to C, this is our radius of curvature, capital R. So we will put this all the value here. So we get N1 upon OM, that is N1 upon OM, and the value of OM is minus U, plus N2 upon V, and here N2 minus N1 upon R. So this is our value. So we can write N2 upon V. First we will write the positive term. So here we can write N2 upon V minus N1 upon U is equal to N2 minus N1 upon R. So this is our formula which gives us the relation between refractive indexes of both the mediums, and this is our image distance, object distance and radius of curvature. Now we will have the example: the light from a point source in air falls on a spherical glass surface which has the refractive index n is equal to 1.5. So we have the n2, here we have the example. So n2, that is 1.5. In the medium n1 is air, so we will take here n1 equal to 1, and the radius of curvature, that is our 20 centimeter. So r is equal to 20 centimeter. The distance of the light source from the glass surface is 100 centimeter. So our object distance, that is u is equal to 100 centimeter, and now we are supposed to find at what position the image is formed. So we are supposed to find image distance V. So we will put here the formula. If we put the value of this value in this formula, so N2, that is 1.5 upon V minus N1 is 1 upon U. So the value of U, that is minus 100. So minus and minus will be plus. So here we have 1 upon 100, that is equal to 1.5 minus 1 upon the value of R. The value of R, that is 20. So we have 1.5 by V is equal to 0.5 by 20 minus 1 by 100. So we can write here that we have the value 1.5 upon V, that is equal to, here we can write 5 by 10 into 20 minus 1 by 100. So we can write 100 into 5, that is 500. 10 into 20, so that will be minus 200, and in denominator we have 100 into 200. So we have the value 100 into 200, that is 20,000, and here 1.5 upon V. So the value of V, that is equal to 1.5 into 20,000 upon 500 minus 200, that is 300. So we have the value V is equal to 100 centimeter. So we can write here that is equal to 100 centimeter. So we can find in this way the image distance V is equal to 100 centimeter. So the further discussion will be done in our next session. Today we are stopping here our lesson. Thank you. Have a nice day.